What we're going to discuss today is no video conditions on a LCD TV. What we're going to go through is some quick tests that you can conduct to find out what may be creating a no video condition. One of the first things that we're going to do in here is we're going to determine if video is present or if maybe the backlights are just not functioning. Some of the no backlight condition has been covered in the no power video that's already been provided. So what we will do is do some additional testing to find out whether we do or do not have video on the screen, due to the fact that your backlights operate totally independently from your video processing circuit, until we get into the area where we're talking about local dimming control, which is also covered in the no power video. What we're going to start out with is we're going to start out with the switch mode power supply. The reason we're going to start out with the switch mode power supply is due to the fact that some of the voltages provided out of the switch mode power supply to the main board actually allow the main board to use those voltages to regenerate other voltages for your tuner circuit, your switching circuit, and your processing circuit to actually process the video information coming into the TV and convert it to LVDS, low voltage differentials, and provide that information to the TCON board. We're going to use one that has a TCON board as an example in this unit, but we will also briefly mention as we proceed through some of the differences between some of the units that have a TCON and some of the ones that do not have a separated TCON. One of the critical voltages coming out of the switch mode power supply is your 12 volts and your 24 volts. Many times the 12 volts is the main voltage that's used on the main board for video and audio processing. Some of your other voltages, which most of the newer ones are running at 24 volts, but that voltage can vary tremendously based on size. And that voltage is being used for the audio amplifier. But if you're a technician out there working on a unit and you have a no video or no signal complaint, some of the times whether or not you have audio or not can be a little bit tricky, based on the fact they may be feeding the audio out of their optical, and they have in the customer's menu they have the speakers actually turned off. So without that frame of mind, it may create a scenario where you're actually troubleshooting the wrong thing. So what we're going to do is we're going to eliminate the functionality of the main board and generate a test pattern. You can also utilize the test jig to generate a test pattern, but not in all chassis will that TV jig generate a test pattern. So first thing that we're going to begin with is testing voltages out of the switch mode power supply. Like I said, one of the critical voltages that we want to look at is your 12 volts. But for functionality purposes, we actually want to look at all of the voltages coming out of the switch mode power supply. Testing those voltages, right here on the power supply, you have a screen print that tells you what pin, what voltage is on. We want to start out with our 12 volts and make sure that that voltage is present. In this case, our 12 volts is present. Now we know the main board is getting that supply voltage so it can process the audio and video information that's input to the main board. During the power on process, one of the electronic switches on the main board that's controlled by the micro is your panel control. The small circuit that controls panel control tells the main board to share that 12 volts through the LVDS cable with the TCON board. There are cases that we have had in the past where that 12 volts is not being shared with the TCON board. Many times the TCON board itself, once you get it in a condition where you can get to the TCON board due to the fact it's covered with a metal shield, you will have to remove that metal shield. When you remove that shield, you must put some of those screws back in place to provide a ground for the TCON board. Otherwise, you may create some serious damage to the TCON board or the TFT. So one of the first things that we want to do is we want to verify that the TCON board is receiving 12 volts. In this particular case, I disconnected the LVDS cable. If there are two LVDS connectors, one is always labeled CN1, the other CN2. CN1 is always going to be your 51 pin. Visibly, it's a little wider by 10 pins than the other. And close to that connector is where you're going to find a small surface mount fuse. At that small surface mount fuse is where you should get 12 volts if the switch on the main board is operating correctly. So what we're going to do at this point is we're going to reconnect the LVDS cable. So we will now, when we power the unit up, we will get our 12 volts down to the TCON board. Now when I test for that 12 volts, if the switch on the main board is working properly, because I know I have it coming out of my power supply, then I should have my 12 volts coming out of the LVDS cable. Now, there are conductors here on the LVDS cable on the main board. If you have a damaged LVDS cable, it could prevent that 12 volts from getting to the TCON board. So you can test on the LVDS cable and determine if that 12 volts is there, which right now it's running 11.9 volt, which is sufficient for this to function. The purpose of that 12 volts going to the TCON board is to power the power supply. It's a DC to DC converter that's on the TCON board. All the TCON boards have this DC to DC converter built into them. The output voltages of that DC to DC converter vary from panel type and panel type to panel type and panel design from panel manufacturers. A lot of times you will see on the white label LG display, you may see Sharp, you may see CNI. We use a lot of different manufacturers, and we will use other manufacturers' panels from time to time. But different plants have different engineering groups, and they'll design the panel differently. Due to that, your TCON board will vary tremendously as to what output voltages the TFT panel requires for it to function. In this particular case, we have our 26 volts, we have our 16 volts, we have a 3.3 volts, a minus 5 volts. Many times we'll have an 8 volts and a minus 8 volts. Due to panel requirements for the TFT, those voltages can vary up and down a couple of volts. Some of the times your minus 8 volts may be minus 7. And that 26 volts can be 28 volts. So those voltages can vary slightly from panel design to panel design. But all of those output voltages, your four core voltages, are going to be your 3.3, minus 5, 16, and 26. The 8 and minus 8 and some of the other voltages vary tremendously whether they're present or not. But those are your four core voltages. They can vary up and down a couple of volts that power supply must generate for the TCON board and for the TFT to have operational voltages to work with. The processing IC on the TCON board utilizes the 3.3 for its own functionality. The 3.3, as well as the other voltages, leave through these two cables to provide power and operational voltages for the TFT itself, which is your thin film transistor. To clear up any misconceptions, you've got two ribbon cables that leave the TCON board. This one actually does drive the left from the viewer's viewpoint, the left side of the panel, and this ribbon cable, the right side of the panel. Now, a defect on one side of the panel that lowers one of those voltages or shorts the voltage to ground can be determined very easily if you find a voltage that is absent or running extremely low. You can disconnect either one or both of those ribbon cables at a time to determine, is it this half of the panel or is it this half of the panel? We're really not after trying to troubleshoot and repair the panel itself, but what we're after is to determine whether or not we have a defect on the TCON or if we have a defect on the TFT itself. The reason we're covering this in a little bit of detail is there is a lot of push and they're becoming a little bit more available to where you can purchase just the TCON board itself without having to purchase an entire panel. So discerning whether it's the panel or the TCON is critical. The processing IC on the TCON board itself actually takes video information from the main and converts it to address control information for the TFT. So what the TFT will do is through an X, Y, and Z grid, which thin film transistor, it's actually your emitter base and collector grids, will know what lines to turn on to fire off certain pixels on the panel itself to regenerate the picture. So one of the critical things we want to do is, as we've already done, verify the 12 volts is coming out of the main. We want to verify the 12 volts is getting to and through the fuse. One thing to point out is if the 12 volts going to the TCON board is missing, check the LVDS cable conductors to see if the voltage is coming out of the main board. If the voltage is coming out of the main board, check the fuse on the TCON to see if it's open. If that fuse is not open, check for your secondary voltages off of the power supply on the TCON. If the voltage is not there on the LVDS cable, borrow the 12 volts from the power supply, jumper it carefully to the fuse on the TCON, power the unit back up, check and see if you get your picture. What this jumper is actually doing is doing the main board's job of switching that 12 volt for the main board. Just to verify for the technician that if you replace the main board, then your picture will be restored and your panel and TCON are okay. Now what we're going to do is we're going to look around the power supply circuit here for those secondary generated voltages. Many times if we have training material on the particular unit that you're working on or that panel, we will show you precisely where to test for those voltages. Many times you will see labels such as VCC, different label tags on small test points on the TCON itself. Those are going to be either critical data or critical voltages. So when you find a small screen print on there, it will indicate that that's something that's important. Many times it will label most of the voltages. Now, when we test some of those voltages, we will want to verify that all the voltages are present. If all of the voltages are present, then you don't have a short on the TFT or the TCON. Now, if one of the voltages is shorted, remove both of the ribbon cables, but never disconnect or reconnect the LVDS or any of these ribbon cables with the unit powered on. The static from the disconnect and reconnect will damage either the main or the TCON and possibly both. If you do find a defect or a failure in any of these voltages, the newer units we've gone to a more sturdy connector for the LVDS cable from the main to the TCON. This connector can still have damage to the connections that are on the cable. The older units will have a flat ribbon cable that has a crimp connector on both ends. If any of these conductors are damaged, ripped, or torn, folded over, etc., then what can have happened if those conductors that are damaged supply your 12 volts? What can have happened is the main board and the TCON become damaged due to the fact that some of the data lines have a 12 volt supply being shorted to them when the switch on the main board powers on and supplies 12 volts. When it gets into the data lines, it can go back directly into your processing IC and also go into your analog to digital converter that's on the TCON. So damage to both boards by a defective LVDS cable or disconnecting and reconnecting the LVDS cable while it's powered on can create damage on both of the boards, if not at least one. Now, once we've verified that all of our voltages are present, if we still have a no video condition, there is an additional test that we can do. Many of our newer units, you can use the test jig to actually drive the TCON board itself, independently of having backlights or not. Now, if you want to drive just the T-Con itself, it's advisable, if the power supply does turn on the backlights, to let those backlights be turned on by the main and the switch mode power supply. If they do not turn on, then you may want to refer back to the power supply troubleshooting and force the switch mode power supply into an on state, then force the backlights on. Now, just to get the TFT and the T-Con to produce a video image, what we will have to do is we will have to tap in with a jumper to the 12-volt supply. What I'm approaching is the case where your 12 volts is not being switched on the main board. You will have to disconnect the LVDS cable. Make sure it does not lay across the T-Con and create a problem. What we will do is we will tap into that 12 volts with a needle-to-needle jumper. And we will use a clip so we can attach that 12 volt and safely supply it to the fuse on the T-Con. Now, when you use a jumper like this, you make sure that you don't short that 12 volts to any other conductors on the board. Now, when we power up the switch mode power supply utilizing the main board to do so, we should provide our 12 volts down here to the T-Cons. Then we can safely check the T-Con for all the secondary supplied voltage. What we want to do is we want to make sure that if the main board is not supplying that 12 volts to the T-Con, that we can bypass that function on the main and supply that voltage to the T-Con to verify its operation. Now, if the jig works on a particular model that you're working on, the jig actually carries out this function for you. Now we can check our voltages. Now, the jig will not tell you if the voltages are present. One of the critical voltages that we want to locate is your 3.3 volts, because we're going to utilize that to force the T-Con into a test pattern generation. What we're going to do, and just as a footnote, if you have to do this and you're absent backlights, you can use a flashlight to check and see if the TFT is actually going into the test pattern and creating a video signal. What we will do is, with the 12 volts supplied, what we will do is we will use a needle to tap into that voltage, and we will supply that voltage to connector C and 1. If there's two LVDS cables, then it's going to be your 51 pin, which is labeled CN1, and you will tap that voltage into pin 44 of CN1. Now, a critical point to remember is, as long as you are applying that 3.3 volts that's generated on the T-Con to pin 44 of CN1, it's going to turn on a test pattern generator in this IC. And you will have a test pattern displayed. Now, the test jig actually does that for you. So it can make life a little bit simpler in testing for a video scenario. Okay. Once you verify whether or not you have a test pattern on the screen, if the test pattern exists, then your T-Con and your TFT are functioning properly. If that test pattern does not appear, there can be several scenarios that can create a no video condition. Once you turn this chip on and turn the test pattern on, now it's sending data commands to all of the buffer ICs along the edge of the TFT. That data can also be corrupt by either a defective IC along the edge or internal to this chip. And you can also have some of your voltages vary because now you're driving the panel. That's going to be a very rare case, because once you supply 12 volts and your voltages come up, you have actually turned on this chip and turned on the TFT and the drive ICs for the TFT. Now, if you do not get video, you're going to have either a problem here or here on the TFT. With a video being presented and you've inspected the LVDS cable to make sure that it's not cut, damaged, then your video problem is going to be on your main board. Troubleshooting a video scenario is quite straightforward and fairly simple. Now, there are cases where some of the chassis you do not have a T-con board that's separate from the main. Actually, the T-con board is being embedded in some of the boards along the edge of the TFT or the panel itself. In some of these cases, you cannot use this process to do that troubleshooting. You're very limited on those as to what is happening. In those, which we will not get into an oscilloscope during this particular training session, but in those cases you're going to have to verify that your voltage is leaving the main, and you're going to have to test with an oscilloscope to see if you have video information coming out of the main as well. Which we will cover that in detail in some oscilloscope testing that we will provide for you. As far as no video, this is pretty straightforward and it's a very simple test. It is a little bit tedious using a jumper to provide the 3.3 to pin 44. This connector, to make things simpler, has a marker for every 5 pin. So you don't have to count 44 pins, just count in 5s all the way up to 45, and then it's back 1 pin. And there is usually a round connection point either close to the connector or a brief way away from the connector where you can put the needle in there to supply 3.3 to pin 44. I thank you very much. You have a good day.